I'm Anil Kumar, and now let us understand equivalent linear systems. So the question is, what are equivalent linear systems? Now, second part of this video will discuss how to create an equivalent linear system. Let me correct this. So the second part is create an equivalent linear system to the one shown in the graph below. So first let us understand what are equivalent linear systems, and then we will see how to create them. Linear systems which have same solution are called equivalent linear systems. So let me write it down. Linear systems which have same solution. Are equivalent linear systems. Okay, so that is the very basic definition of equivalent linear systems. Now let us explore it means what. What we are given here is a linear system since there are two lines, right? So two or more linear equations or two or more lines will form a linear system. Solution of a linear system is point of intersection, right? So for the given linear system, point of intersection is the solution, and here solution is the coordinate point as shown here, which is 2, 1, right? So 2, 1 is the point of intersection of these two lines, and that becomes the solution of the given linear system. Now second part is to create an equivalent linear system. So the easiest way to create an equivalent linear system is, once we know the solution, what is the x value? X value is 2 and y value is 1. So x equals to 2, y equals to 1 also forms a linear system, right? Can you sketch it? X equals to 2 is a vertical line, let's say like this, right? So that is x equals to 2, and y equals to 1 will be a horizontal line. So this is y equals to 1, and the earlier one is x equals to 2. Their point of intersection is also same, and therefore from our definition we get a linear system which has the same solution as the given linear system. So that probably is the simplest of all the solution for the given question. Now we can actually create more linear systems. How to create more? One way is we can add and subtract these two equations. So let's add them. So if you add them, you get x plus y equals to 2 plus 1, 3, and the other equation becomes x minus y equals to 2 minus 1, which is 1. So that becomes another linear system whose solution will be 2 and 1. Well, let us check. If I substitute 2 for x and 1 for y, what do I get? I get 2 plus 1 equals to 3. It works, correct? Here also, if I substitute 2 for x, 1 for y, I do get 1, so it works. So the solution for this system is also 2, 1, and solution for the next system which I created is also 2, 1. So likewise, you can very easily create linear systems from the given solution or from the given linear system. Now let's get back to the question once again. Let me write down equation of these lines. Let's call this line as line 1. So I can say line 1 for me is y-intercept is 5. The slope is, if I consider this line, you go down 2. That means rise is minus 2, run is 1. So we can write this equation as y equals to minus 2x plus 5. And for the other line goes through the origin, slope is rise of 2. Rise of 1 and run of 2. So it is y equals to, it is positive 1 is the rise and 2 is the run, so it is half x. It goes through origin, so plus 0. So that becomes the linear system given to us. The graph is given to you. So this is the graph, right? So you will notice that if I substitute x as 2, I get y as 1. That's correct. If I substitute x as 2, 2 times minus 2 is minus 4. Minus 4 plus 5 is also 1. So solution for all these linear systems which we have discussed is a common point to 1. And therefore, all these systems are equivalent linear systems. So with this video, I think you understand how to create equivalent linear systems, and you also understand the importance of these linear systems is that they have a point in common, and that is their solution, the point of intersection, right? I hope that helps. Thank you, and all the best.